Hello everyone, I am Latarani. In this video, I am going to teach you to solve problems on Regula-Falsi method. In the previous classes, we already studied about the algebraic and translational equations are solved by using bisection method and the geometrical representation of the Regula-Falsi method. Today, we move on to the problems on Regula-Falsi method. First one, find the root of the equation 2 into x minus log x base 10 is equal to 7, which lies 3.5 and 4 by Regula-Falsi method. Answer. Let us consider f of x as 2x minus log x base 10 minus 7, because the given function is always f of x is equal to 0. Therefore, the given equation can be taken as 2x minus log x base 10 minus 7 is equal to 0. Consider x0 is equal to 3.5 and x1 is equal to 4. Here we have to find out f of x0 and f of x1. Therefore, first we type the function f of x in the calculator. First we press alpha and closed bracket, we get x into 2 minus, here we have the log base 10. Therefore, press log. Again x is there, press alpha and closed bracket, we get x value, then close the bracket, then press minus and 7. Now here we have CALC calc, press calc, we get x question mark, press x value, that is 3.5. We get the value minus 0.5440680, but here we consider only 4 decimals, that is 54406. 5 decimals are considered. And again press calc, then x1 value is 4 equals, we get 0.3979. Here f of x0 is the minus value and f of x1 is the positive value. That implies f of x0 and f of x1 are the opposite sign. Therefore, the given interval lies between x0 and x1. We write the first approximation, x2 is equal to x0 into f of x1 minus x1 into f of x0 whole divided by f of x1 minus f of x0. Now substitute x0 value 3.5, f of x1 is 0.3979 minus x1 is 4, f of x0 is minus 0.54406 whole divided by 0.3979 minus of minus 0.54406. Simplified, x2 is equal to 3.7888. Now find f of x2. Here x2 is equal to 3.788. Then consider find out f of x2, that is 2 into cos, 2 into x, means answer, minus log base 10, that is log of answer close the bracket, minus 7 equals. We get minus 0.0009. In the calculator we get minus 9.0168 into 10 to the power of minus 4. We convert into the decimal point like that, minus 0.0009. Here f of x2 is negative, that is less than 0. This negative value replaces the previous function, that is f of x0. Hence, the root lies between x1 and x2 because the product of f of x1 and f of x2 is less than 0. Therefore, the next approximation x3 can be written as x1 into f of x2 minus x2 into f of x1 divided by f of x2 minus f of x1. Again, substitute the values of the numerator and denominator. Here x1 is 4, f of x2 is minus 0.0009 minus x2 value 3.7888 into x1 value. What is x1 value here? 4, and also f of x1 is 0.3979. 0.3979 whole divided by f of x2 is minus 0.0009 minus f of x1 is 0.3979. Find out the values in the calculator. We get 3.7892. Comparing this x3 value in the previous x2 value. Here up to 3 decimal we have the up to second 2 decimal we have the same values. 3.78, here also 3.78. In the third decimal we have here 9, but here we have the 8. But up to after the third decimal here we have the 4. Therefore, third decimal is added by 1. Hence we get 8 plus 1 is 9. Hence the x2 is nearly equal to x3. Therefore, the required solution is 3.789. Now we go to the another problem. In the previous problem, the equation containing the logarithmic function, but in this problem, the given equation is containing the trigonometric function cos. Find the root of the equation cos x is equal to 3 into x minus 1 over the intervals 0.5, 1 by Regula-Falsi method. Let us consider the given equation as cos x minus 3x plus 1 is equal to 0. Then consider LHS as a f of x. Here x0 is 0.5 and x1 is a 1. Find out f of x0 value and f of x1 value by using the calculator. See here, the given equation containing the trigonometric function. Therefore, now we have to find the values in radians. See here, our calculator is always in the degree. Therefore, we have to change from degree to radian by using shift and mode. Then we get so many terms here: degree, radian and also gradient. We see the radian value. Radian is under 4. Press 4. Then our calculator reading is converted from degree to radian. Now first type the function in calculator cos x minus 3x plus 1. See here, cos alpha closed bracket, we get it, type the x value, then close the bracket, minus 3, again press alpha closed bracket, that is x, plus 1. Now the function is cos x minus 3x plus 1 is displayed in your calculator. Now press CALC, calc, then we get the x value. Put x value is a 0.5, Then we get value 0.37758 or 56. And also press calc. Put x value as a 1. Again press equals. We get minus 1.45976. Here f of x naught is a positive and f of x1 is in a negative. Therefore, its product is less than 0, or f of x naught and f of x1 are of the opposite sign. Hence, first approximation x2 can be written as x naught f of x1 minus x1 into f of x naught whole divided by f of x1 minus f of x naught. Substitute the values of x naught f of x1 and x1 f of x naught in numerator and also denominator. Simplify. We get x2 is equal to 0.60275. Then press answer. What is the answer here? 0.60275. This is the answer. Now find out f of x2. F of x2 is means f of x2 means we know the f of x value. What is f of x value? Cos x minus 3x plus 1. Therefore, press cos answer, then close the bracket, minus 3, again press answer, plus 1, press equals. What we get? We get the value 0.0155, which is greater than 0. Hence, f of x1 into f of x2 is less than 0. That is, the root lies between x1 and x2. Hence, the next approximation x3 can be written as x1 f of x2 minus x2 f of x1 whole divided by f of x2 minus f of x1. Again substitute the values. We get 0.60692. This is x3 value. Comparing x3 in x2, here we not get the same value up to third decimal. Here up to third decimal we have 602, but here we have 606. Hence we goes to the another approximation. For before that, find out f of x3. Here f of x3 is 0.000623. Again it is greater than 0. Therefore, the given roots lies between x1 and x3, because f of x1 is negative, f of x3 is positive. Therefore, its product is less than 0. Hence, the next approximation x4 can be written as x1 f of x3 minus x3 f of x1 divided by f of x3 minus f of x1. Substitute the value and simplify. We get 0.6071. Now comparing x4 is with x3. Here x3 is 0.6069. x4 is 0.6071. Here up third decimal is up to third decimal 0.607 is there. In the previous x3 0.6069. So we have to add by 1, then we get 607. Hence x3 is nearly equal to x4. The required root is 0.6071. Okay, next one, another problem. In this problem we have the exponential and also trigonometric functions. Find the root of the equation x into e to the power of x is equal to cos x, which lies between 0.4 and 0.6 using Regula-Falsi method. Again, rearrange the given equation. F of x is equal to 0 form. Therefore, this can be written as x into e power x minus cos x is equal to 0. Then LHS as f of x. Consider 0.4 is an x0 and 0.6 is an x1. Now we type the function x into e power x minus cos x in the calculator. Alpha, press the closed bracket, that means display the x in the calculator, into e to the power of x. E to the power of x is nothing but again shift ln. Shift ln, then x is there, alpha closed bracket, then display is x into e to the power of x. Next minus cos alpha closed bracket, x will be displayed, then close the bracket once again, we get x e to the power of x minus cos x. Then press calc, give the point 0.4 and press equals, we get minus 0.3243. And also press calc, give the value 0.6, press equals, we get the answer 0.2679. 2679 can be written as 268. Here f of x naught is in a negative, f of x1 is in a positive. Therefore, these are the opposite sign. Hence, the first approximation x2 can be written as x naught f of x1 minus x1 f of x naught divided by f of x1 minus f of x naught. Substitute the value, we get x2 is equal to 0.60275. Now find the f of x2 for this value. F of x2 is minus 0.0249, again which is less than 0. In the previous, f of x naught is less than 0. Now f of x2 is less than 0. Therefore, x2 replaces the x naught. Hence, f of x1 into f of x2 is less than 0. Therefore, the root lies between x1 and x2. The next approximation x3 can be written as x1 into f of x2 minus x2 into f of x1 divided by f of x2 minus f of x1. Substitute the values of x1, f of x2 and x2, f of x1 value, we get the value 0.5172. Now comparing with x2 value, previous x2 value, here answer is not same. Then we goes to the another approximation. Before that, we find out f of x3. Here f of x3 is minus 0.00168, which is less than 0. Therefore, x3 replaces the x2 value. Therefore, x1 and x3 are the roots. Hence, f of x1 into f of x3 less than 0. Therefore, x4 can be written as x1 f of x3 minus x3 f of x1 divided by f of x3 minus f of x1. Substitute the value x1 f of x1, x3 f of x3, we get 0.517716. Again, comparing with the previous term x3. Here x3 is 0.5172. Here x4 is 0.5177. Up to third decimal, we have the same value 0.517. Here 7, but in the previous 7, 2. Here we have to find out up to fourth decimal. Therefore, we go to the another approximation, that is x5. Before finding x5, we need f of x4 value. Find out f of x4 value, that is x4 into e to the power of x4 minus cos into x4, we get the value minus 0.000107 less than 0. Hence x4 replaces x3 value because f of x3 takes negative value. Since f of x1 into f of x4 is less than 0, hence the root lies between x1 and x4. Hence, the next approximation x5 is equal to x1 into f of x4 minus x4 into f of x1 whole divided by f of x4 minus f of x1. Simplify, its value is 0.51774. Now, comparing with the successive terms x4 up to 4th decimal, we have the same value, that is 0.5177. Hence, the required root is 0.5177. Thank you.